In this video, we're going to talk about what dot products are, the properties of dot products, and then practice finding the dot product of a few examples. So the dot product is used when we're multiplying a vector times a vector. Now you would think that this product would yield another vector, but that's not the case. When we multiply a vector by another vector, we actually come up with a scalar. So when we're multiplying, let's say, a vector u, which has components u1 and u2, with vector v, which has components v1 and v2, what we're going to do is we are going to take the u1 and multiply it by the v1, and then we're going to add that with our u2 times our v2. And that's going to produce our scalar. So what are the properties of the dot product? So let's assume that u, v, and w are vectors in the plane or in space. And we're going to let c be a scalar. So we have 5 properties. We see that the commutative property of multiplication holds. We also see that 0 times any vector is still going to be the 0. We also have the distributive property. We are told that a vector times itself is going to produce the magnitude of that vector squared. And then we also have the associative property. So let's practice finding the dot product on a few examples. All right, so let's start with our first example, where we have vector, let's call this one our vector u, which has components 4 and 5, and vector v, which has components 2 and 3. Let's remember that our dot product is the u1 times the v1 and the u2 times the v2, so we can go ahead and plug those in. And so we have 4 times 2 plus 5 times 3, which is going to give us a value of 23. So here, our u times v produces the scalar 23. So let's try letter B. So now we have a vector u with components 2, negative 1, and vector v with components 1, 2, which is going to give us 2 times 1 plus negative 1 times 2, which is going to give us a value of 0. Let's go ahead and let's try our third example, letter C, with a vector u of 0, 3 for components, and a vector v with components of 4 and negative 2. So let's go ahead and let's plug our numbers in and see what we get. So we have 0 times 4 and 3 times negative 2, which is going to give us a value of negative 6 for our scalar. And that's how you find the dot product when you're multiplying two vectors.